In this video clip, we learn two-way ANOVA. We collect data using two-factor factorial design. That is, we collect data for each combination of levels of the two factors under study. We focus on balanced two-factor factorial design, where sample sizes are all the same. In a two-way ANOVA, we examine the effect of two factors of interest on the dependent variable. For example, we may study percent carbonation and line speed on soft drink bottling process. We also examine the interaction between the different levels of these two factors. For example, we may want to see whether the effect of one particular carbonation level depends on which level of the line speed is set. Consider two factors of interest, namely A and B. Let R be the number of levels of factor A and C the number of levels of factor B. Then n prime be the number of replications for each cell. That is, each combination of levels of the two factors, or n prime is the sample size. N is the total number of observations in all cells. So n equals R times C times n prime. So n is the total size of all the records in the samples. Then let xij(k) be the value of the kth observation of level I of factor A and level j of factor B. So again, we can consider different sources of variation like in one-way ANOVA. Here we have SST equals SSA plus SSB plus SSAB plus SSE with degrees of freedom as follows. Then we can define MSA, MSB, MSAB, and MSE accordingly. Then here, in the null hypothesis, we have mu1 equals mu2 equals mu r regarding factor A. In H1, we have not all the mu i's are equal. Here we do not consider factor B specifically. So here we have an F-test for factor A effect, where the F-test statistic equals MSA over MSE, and we reject H0 if the F-test statistic is greater than the F critical value. Similarly, we can test the effect of factor B. In addition, we can test the interaction effect of factors A and B. We will explain this later. So this is the two-way ANOVA table. Then we can see here we have F statistics regarding factor A, factor B, and the interaction of factors A and B. Here we have some features regarding two-way ANOVA. First, we have degrees of freedom add up. That is, we have the total degrees of freedom equals the degrees of freedom of the error, factor A, factor B, and interaction components. Second, we have the sum of squares add up. We have SSA equals SSE plus SSA plus SSB plus SSAB. Further, we have that for the different F-tests, the denominator is always the same, but the numerators are different. interaction effect means that the effect of one factor depends on the levels of another factor. In this part, we observe no significant or no obvious interaction because for different levels of factor B, levels A, levels 1, levels 1, 3, 2, we observe the same pattern for the effect of factor A. But in this case, we observe some interactions between the two factors. So here we have that when factor A level is low, we have factor B level 3 is the top. But when factor A is at a medium level, then factor B of level 2 is at the top. So here we have some evident interaction effect of factors A and B.